Okay, so hello everyone and welcome to second virtual meetup of Berlin Machine Learning Group. And today we have four amazing speakers talking about conversational AI. And this meetup is very interesting to me because I work in conversational AI, so I'm hoping to learn a lot of new things that I can use in my day-to-day job. And over to you, Daniel.
Hi, it's me, Daniel. Thanks. I was going to introduce our first fantastic speaker today. I'm a little bit confused because the YouTube page says it's Mia and the meetup page says it's Christian. Could you clarify? It's Mia, I think, right?
It's Christian.
Yeah.
All right, all right. So it's going to be Christian. I'm happy to introduce Christian. Christian is founder and CEO of Hololux. He helps his clients use technologies like mixed reality AI. I hope he's still got his background on. You'll immediately see that that's his mixed reality is his passion. Also, serverless computing. Last year, he became for the 10th time in a row. He received the Microsoft MVP award. So I guess that's just one of the reasons we're very excited to have him here today. Christian, over to you.
So yeah, thank you. Welcome to my session. And you see, I'm in the home office in Corona lockdown and couldn't go to the hair cutter for a longer time. So I think the first thing is I should share my screen. 1 second. So, can you see my screen? Can somebody confirm that?
Yeah.
Okay, great. Yeah, then welcome to my talk, Microsoft AI platform. We have today more talks about the Microsoft platform. And I want to give you a short overview about the platform. And Trent already warned me that you guys are not too interested in platform talks. So we will play a little more, let's say it's more a code introduction then. So we go fast over the features that Microsoft offers, over the tools, and then we look a little bit at the code. So I have a developer background, but Mia is also an MVP, and she has a data scientist background. So we are glad to answer the questions about the platform later on together. And I do the presentation for the first time in Jupyter Notebook. So cross your fingers that will work. Okay, the first thing I'm a little interested is what is about you? What is your profession? And I've prepared, let me run it, a little poll to know a little bit more about your background. Let me see. Yeah, come on. Yeah, here we go. Here's a little barcode, a QR code. So it would be great when you just scan it and answer if you're a developer, hobbyist, data scientist, data engineer. So all we speakers have later on maybe a little more ideas about your background. So I was the first one who filled out the developers. So I wait a few seconds. Like always in live demo, it looks like it does not automatically refresh. Really? Yeah. Then it may well not work. Yeah. That's a little pity, but anyway. So let's go further. So the question is, what should an AI platform provide? And every big vendor is currently crafting their AI platforms. And there was also a Gartner research about a Gartner study, which are features that the platforms need, which are the visionaries, which are the leaders. And the outcome was interesting. Currently the leaders in this area are rather smaller companies. And for example, Microsoft and Google, they are in the visionary part, and they lack a little bit of the on-premise experiences for the AI platforms. That's why they are in the visionary section. But interesting is Amazon even did not make it to the chart at all. They are the honorable mentions, and also the SAP is not in. So anyway, what does a platform need? You need, for an AI platform, you need model development and training for sure. The platform should support that. Model scaffolding, I mean, that's actually running the model later on live and do the prediction with a trained model. Then you need tools that support you in the area of data engineering to prepare the data and to deal with big data. And you need model operationalization, like meanwhile you call it ML ops. And we later on have a talk with Marvin, who goes deeper into that topic, how you can automate your machine learning processes. And for sure, a platform should offer the compute power so that you're able to run your experiments. So the Microsoft has a lot of tools in this area, actually, and it's even a different focus. So it's a little pity that you need authentication for the poll, because they're tailored for a different person. So that's there we have, for example, the Power Platform. That's a low-code, no-code solution from Microsoft where everybody can build apps. And this platform has a feature that's called AI Builder. And I would say power users are able to use AI in their models. You have a pre-trained model for category, entity extraction, form processing, object detection, predictions, and things like that. And it's pretty easy to use. Almost everybody can use this. Then we have the cognitive services. I think they are rather developer target. That's a great thing for developers. You have already pre-trained models that you can use, or you can even customize them on top of what's pre-trained from Microsoft. And we have things like Vision API, like speech AI, language understanding. Mia later on will have a talk about the language understanding feature and compare it also with some other vendors. We have different out-of-the-box services for Microsoft. I think that's more interesting for the developers. You don't need to know much about machine learning. And for example, it's like the Vision AI. You upload via REST request. You send a picture, and you get back the data. Where is what, and which confidence has it about the objects, and things like that. There's also custom Vision AI where you can train yourself. You upload models and text things, classify things, and afterwards you can export this model. So it's really a great start for developers. And then we have the Azure Machine Learning. The Azure Machine Learning, that is rather focused on the data scientists, data engineers, and also a little bit for the developers. So I think that's for this meetup and for this user group, I think that's the right tool, and we will have a look closer into this tool. So, and we saw already some tools, and I just want to show you a little way which way you should go. So we already talked a little bit about when to use what. And we will not use the low-code thing that is for power users. Then Mia will later on talk about use pre-built models with especially in it's not mentioned here, but with LUIS, with language understanding intelligence. And we will now in this talk focus a little bit of build your own model. That's all. Sorry, this is all this area here. And you have also two important choices here in the Azure Machine Learning. You can have a code-first experience, and you can have visual tooling. And that's also pretty interesting. I hope we have time to explore all of this live. And that's what we focus on this time in this session now, is a little bit to get a more introduction, a kickstart into the Azure Machine Learning area. So I show you the backend, how it looks like. I think you should be able to read that from the size. So this is how the Azure Machine Learning looks like when you create it. This is a rather new experience. It's the preview experience. So it's all under one workspace. So it's also mentioned as the Azure Machine Learning workspace. And you see already many different things that you have here. I start from the bottom up. You have data labeling. I think you know what's that for, so that you can classify your training data. You have data stores. You can register different data stores where you pull your data for the training. Every workspace has a default blob storage, file storage, but you can also add additional storages like a SQL server or a data lake or MySQL. You can register different stores where you can pull your training data from. And then for sure, pretty important is the compute power. And you even see the COVID-19, it's affected everything. Even here's a warning that when you use free instances or sponsored subscription like I do currently, that you then maybe have a degraded performance. And you have different kind of compute that you can use here. You have a compute instance, and that's rather where my what you see in the background, my Jupyter notebook is running on one of this instance. I don't have all the machine learning tools installed on my box, so I host the box at Microsoft that I can scale like I want, and there are many tools already pre-installed. And I currently use exactly this Jupyter notebook here from this box. So you can set up your own development environment here. And then you have the compute clusters where you can, on demand, set up the compute. And you see you have also the choice for a cluster if you have more CPU. If you need rather CPU processing, or if you rather need a little more expensive GPU processing. And you can have a dedicated machine. That means it's always reserved for you, so it's a little more expensive. Or low priority, what I'm currently used, then it's a kind of a shared compute power, and you have to wait a little bit till something is available. And you can really, you have really a lot of choice how high you can scale these boxes. There's really a lot of choice. And as I said, currently of Corona, some of the instances are even not available currently because there's a heavy load on the systems. So you have the compute clusters, then you have inference clusters. That's where later on the trained models are running, and you can do the real-time predictions. And you can attach compute. For example, you can attach Databricks compute, or you can attach your own Kubernetes cluster or your own VM, so you can bring in your own compute power here too. So you have endpoints. That's where you can access the trained models later on for do the real-time predictions. You have a registry for the models that automatically get versioned, so you can track some output like the performance of the model, and can compare that with different versions of the model. So you have here a model registry, and also the model is there, so you can download the model, or you can reuse the model, or you can import an already pre-trained or trained model. So you have pipelines That means you can combine many of the steps, like data preparation, and then do the training, and then publish the endpoint. I think that we don't want to talk about this today, because that's already covered in the next talk, with the DevOps talk, with the ML talk. Then you have the experiments that are the actual running. That's the process run the things. You have the logs and everything they bring out. And then you can configure data sets. I have already here some pre-configured data set. That means you can here bring in files, or you can bring tabular data. And you can create it via the user interface, or you can create that later on via the SDK. You have a designer that helps you. Let's see, for example, I think I have something from soccer results here. And you have a designer that helps you to already pass the CSV. You can say, okay, this is the header file with the data. And so you can easily prepare the data in simple cases in the data sets. And you have them, you can use them later on in all the experiments. Then we have the designer, where we'll have a look later on. That means you can have a graphical designer to design a machine learning pipeline. We have a feature automated ML. We will check out later. That means it automatically looks for test many different algorithms and to find for you the best matching algorithm. And then we have that what the data scientists use most. We have the Jupyter notebooks, or the notebooks here in the file storage. So that's a little bit what you have in the backend. Most of the time, or many of the things you will do with the SDK, what we will do in the next step. So let's see how that really works in the SDK, how a flow would look like. So you have, with the code, you have to connect your workspace. So what we saw in the website, that was our workspace. And you connect that programmatically with this SDK. You can run that on your local box. You can run that on a hosted box, like I do in my demo. And now it's connected to my workspace. The next step you would do is you have to prepare the data. So you see here, you have also a class for that. You import the data set from the Azure ML toolset. And before, we saw already some data sets, but that's a programmatically way how you upload them. We have a diabetes data set. We don't use COVID-19, because you can open every news and you find a lot of COVID-19 analytics. So we use diabetes. So we upload this programmatically to our data store. Pass the delimited file, and just that we have the data there. That's one of the steps. So, okay, it's now registered. The next step you would typically do is the training. So I just create a folder where we store the scripts. So that's not. And this file we will not execute here. I just write this file to my local storage here on this box, and will execute that later on a such called estimator. That is what actually doing the training. And so we write this file in a folder, and we'll use it later on as a startup. So we give some parameters inside. And as I said, this script will later on usually not run on my box. For sure, you can also run it on your local box. But the idea is you let that run on a cluster. And you can give parameters for your algorithm, like here for the regression, the regularization. And important is in the run, you get a run context where you are able to log also some data, some pictures, or some performance, some metrics about your training. And what we also see here is we give in the input data set. So we also use the data set that we registered before, or one of the data sets that I've shown before in my workspace already. So that's abstraction from the current data. So you don't access the data store directly. You go over the abstraction of this data set. So then we just do a little preparation of the data for the features, the label, do a little split, I think that's not really the interesting point for you. So that's what currently your algorithm would run in. Later on, important is we also, that's what I say, you can log different things and to the run context, and you can access that later on to the run and check all the runs and all the results from this. And later on, at the last step, you should export your model, usually in an output folder, and you can download that and run and register that as a new trained model. And you see the performance, it's versioned, and then you can check which version you later on want to use from your model. I think I'm not sure if I forgot to run this. So we just write that to the local file system here. It should not take too long. Okay. Then we define an environment where we want to run our experiment, and the environment is usually based on Docker. And the important thing is here, I define for an environment different conda package, different Python packages that get installed. There are also some pre-configured environment where already scikit-learn or something like this is already included, or you can have your own package. And that are the requirements for your experiment to run. So then you register this environment so that you can use it. Now let's check that we do that. So we register this environment. So the next step is, that's how you run the script on the local box, on the system I'm just working on. And we give the parameter in that we defined before in the other script. Now in this part, we pull the data set that we need, and we give it as in a such called estimator. That's what the run executes on the box later on. And you have to give in the source directory. That's where I wrote the file before. We give in the data set. That's the named data set that I defined before. We say which compute target. In this example is the local compute, but here you specify your cluster or your local compute. You say which environment, that it knows which dependencies have to be installed. And for sure, that's the script we wrote on the disk. That's the actually Py file. So, and then we create that experiment, give them a name, and submit it for run. Then we can, let's run it. And with this run details run show, we will see the output of the experiment while it's running and see how the progress is, how all the stuff get installed. So now it's running. So I don't want to wait now until all this is over, because we lose a little bit too much time for this run. So let's go to the next thing. That's what you usually would do in reality. In practice, is you would run it when you have more complex things to do. You would run it on a remote cluster. These are just some steps that you have to do to set up a cluster if it's not already defined. In my case, it is already defined, so I can even skip this. And then the only difference here is that you have here the cluster name. You say it's not a local box, it's the cluster name you want to run it. That's the cluster that you saw before when we worked in the Azure Workspace and the website. You define the cluster, and it's a combination. You have the Docker container, and it have all the dependencies you have to run for your experiment, and then you have the compute power. Actually, the Docker container with all the dependencies get deployed to this cluster and execute your experiment. That's actually how it works. And then the rest is exactly the same as before. And when the experiment is done, there is a step that you should do is you should register the model. Then you have it as a registered model. And yeah, you have it then in the portal. You see it there. You can download it. You can use it. You can give it an endpoint to use real-time predictions and can manage it from there. These are currently the steps that you usually have. You have the data preparation, upload the data sets, then you have the training step. Yeah, I think Marvin will show a little bit more how you can orchestrate this better with a pipeline and with GitHub. So then we have the designer. I think that's something rather special that you did not use before. Let me see where I have the studio. Where does the designer hide? Here he is. So that's the designer. I took the same experiment, I think, and this is how it looks like when I build it graphically. Now the Windows gone. 1 second. Here we go again. Maybe put it on full screen. And I have to check of this resolution that it's... I hope you can see it like this. So you have also the data sets that we saw before, soccer data set that I had, and the diabetes data set. The data sets I registered before. Then in this case, I decided to use a little algorithm to, it's also just a building block that you can use from all the building blocks that you have here. It's a filter-based feature selection, means I use a little AI already to find the best working features for the diabetes diagnostic. Then I just do a little data split here. And yeah, split it, 60% should be the training data. It's also just a simple building block that you have here. So in one part then goes to the train model, and the train model is a combination between an algorithm. Sorry, when I click on it, it always goes up. So you need the data and you need an algorithm that actually trains the model. And you have already a lot of predefined algorithms that you can configure. You have the boosted decision tree, you have a linear regression, you can also have a neural network regression, you have classification models, you have different models already. But you can also write your own R scripts, you can also bring Python scripts in. So you have, as a data scientist, also the chance to don't only use the pre-configured things, and you, the parameters, you also can bring in your own scripts. Then you do the training. Then you score the model and check evaluate the model, see how the end result from the performance of the model is. And we don't have enough time now for showing all this. And when you're happy with this model, you just can click here, create inference pipeline, and then you publish this model as an endpoint, and you can use it via REST service to get push data in and get real-time predictions out of it. This is a run that I already started. In the designer, what is really nice, in every step of this, you can visualize the results of everything. And we see here the data. Oh, interesting here, the feature recognition, say the pregnancy seems very important for the diabetic. And you see all the data here and the performance of the model graphically. So it's another way to build things like this, is to use a graphical tool, use the same data sets, but instead of writing a notebook like we did before, you do it here in a graphical way. And yeah, what we also have is automated ML. So this takes a while till it's run. So I also use, again, our diabetes data. And actually, this gave the best result of my diabetes prediction. So let's open this run and see what had happened actually. The accuracy is here is 0.96. That was the best I had with all the other experiments. So that's the best results. And here you see what actually happened with the automated ML. You see all the runs with the different setups and different algorithm it tries. And you see what the result actually is. And you see there are a lot of runs with different algorithms. You have also the chance to give some parameters in and to tune it a little bit. But the idea is it tries many different models and give you the best one. And in this case, it was really better than all the other things. So this works very well for, let's see what you can do with it. I think that's an interesting feature. You first define, let's say you want to predict the soccer results. I have the soccer data set that I already registered. Just give it a name. And then you see from the data set, because it's already passed, what's the target column. We said the result should predict the result. You need a cluster. That's the same cluster I used before. I have to give the experiment name. I think I have it already. We use a soccer prediction. And then you see what you can actually do with this. You can have a classification. It's a new feature that you can also use a deep learning here. It's a preview. You can do a regression, or you can do a time series forecasting. These are the options that you have in this automated ML space. So this was a really quick overview. That's I already showed you that. And so I see I'm almost in time. I'm only 3 minutes too long, but we still have the Q&A. So I hope I could give you a very quick overview of how it looks like, how you can work with the Azure machine learning tools, with the Microsoft tools, what they have. I hope you find some useful things in it. And yeah, we're now glad to answer your questions.
Thank you, Christian, for your introduction. There are a couple of questions. Actually, I have one. Could you somehow share the platform poll that you cited in the very beginning of your talk? There was a Gartner report, or what was it?
The Gartner statistic?
Yes.
Yeah, I think, I don't know if can we maybe send later on a...
Yes, that would be great if you could share it on the
event. I can put in the reference from the article where the Gartner chart from 2020.
Great.
Sure.
Thank you. Here's a question. What is the best way to upload a large data set, say of images, to the Microsoft AI platform?
Actually there are plenty of options. What we saw is we can register the blob storage. That's a really large storage, or the Azure data lake, which is capable to hold many data. And a tool that Microsoft used to pump a lot of data in something like this is such called Azure Data Factory. But you're also free to use any other script or whatever you have to push the data in. But the Azure Data Factory is optimized to transport a very large amount of data from very different systems.
I see. Can data also be versionized as the models?
Sorry, I didn't get that.
Can data also be versionized? I mean, you said that the models are versionized. Can you do the same for data? So you can build up a data set.
You can save the data.
Okay. Then there's a question about hyperparameter tuning. How is that handled within the platform?
That's a question that I would rather route to you.
Hi. I said that. So regarding the hyperparameter tunings and AutoML, so usually, like when you set up an experiment, then the AutoML will run the parameters for you. So basically, you don't have to specify the hyperparameter settings. You would kind of like search the best parameters for you. Yeah, as I understand.
Thank you.
Yeah.
Then there was a question if all the developer APIs all hook up into the same underlying services inside Microsoft.
I couldn't hear that well. What's with the SDK with the API?
So the question is if all these developer APIs all hook up into the same underlying services inside Microsoft.
I actually cannot answer what's Microsoft use all in the background, but it's all the APIs target the Azure Machine Learning workspace. Yeah, it's all under Azure ML namespace.
I see. Okay, thank you very much. I think that's all the questions that were asked, and let me hand over the mic to you, Trent.
All right. Hi, everyone. And it's my pleasure to introduce the second speaker, who is Mia Chang. And here's her background. She has a master's in CS background. She has had roles as a backend engineer, data consultant, and data scientist from traditional AI theory practice. She's also a Microsoft AI MVP with a focus on computer vision and deep learning apps. And you'll find her speaking in many different tech events, workshops, having podcasts, and of course in this event here. She's also published her first co-authored book, Microsoft AI MVP book. It's on Amazon Kindle. That was last year. So feel free to reach out to her about data science projects or architecting that, or machine learning ops topics. So Mia, please take it away.
Hello. So I guess I will start. Okay. Okay, so I guess I will just start it. So today I'm going to share you a topic regarding like how does the conversational AI application work. So I suppose there are some people work as data scientist, backend engineer, or software engineer, etc. And then also for me, basically I mostly focus on like computer vision, text analysis, and recently like conversational AI is like new topics for me. So I'd like to share some of my learnings with you. So there's some background about myself. I work as a data scientist in Achilles, and I'm also a Microsoft AI MVP for 3 years. So last year, I published a book with other Microsoft MVPs. It's called the Microsoft AI MVP book that you already could find it on Amazon Kindle. And this year, I also co-authored another book with other 3-4 MVPs in States and in Norway. And the topic also is about like Microsoft cognitive service, what AI is about. So if you have any questions about the talk, or if you buy the book and then you find you have some question regarding it, you could connect me on LinkedIn or send me a message on Twitter. Okay. What is MVP, minimum valuable product? Okay, I think it's a really good question. I saw Jennifer ask on YouTube. So basically, Microsoft has a program called a Most Valuable Person. That means professionals, as I remember. So that means they will award some people who dedicate a lot of time in community talks or do a lot of blog or do a lot of like YouTube video. So for example, if you search Microsoft MVP, you will lead you to the website, and then you have found like around the world, there are a lot of people that actually running different communities events. And then they are awarded as this Microsoft MVP because mostly regarding like community contribution. So actually for me, it's kind of like really feel interesting to involve in this program. Yeah. Okay, yeah, so like certainly posted the abbreviation for the Microsoft MVP. Yeah, so I think that's it. You could search on the internet and to know more about the program. Okay. Let's continue to the talk. Today, I'm going to share you more about conversational AI, like what is conversational AI about, how the industry work with it, and then what if you want to start with it, what service you can find on Microsoft that you could start with it, or if you're not happy with the API, you want to hack by yourself, like you want to do more algorithm from your part, like there are also some libraries that I could share with you. Okay. So what is conversational AI? So basically that every day you will heard people saying like voice assistant, chatbot. I think that's also like kind of like conversational AI applications. It's kind of application between humans and robots. And then also it's able to interact with humans. So you can imagine like if you have a chatbot, like when you just send something to a fans page now on Facebook, some fans page will set up like a chatbot, like automatically reply you when you say hi, and then they will say, hi, this is something fans page, what can I help you with that? So they kind of like set up some auto reply to you so that they could save some time, so then they could save time to give you more important questions and answers. So for example, if you are just asked about what's your next meetup, so it's kind of like a previous, you could just automatically reply the next meetup detail. But if you are asking about, hey, what would be the platform that you're using and what would be the time and the details that I should look at into, then the humans could come into and provide you more details about the event. So when you think of like conversational AI, you could start to think of like a machine try to simulate as like human behavior, and then try to make users to have the feelings like they are really interact with humans or interact with the bot. Okay. So basically, like you could see it everywhere, like at home, on your way to the office or school, in the car, or at work. So actually for me, when I see this picture, I already could start to think of like, oh, what kind of the applications I could make. When you see like the right hand side, people are in the factory, they are doing things at work, they're really busy. So during the time, maybe they are really busy at like putting things together. So they basically don't have time to take up their phone and then read a message. So if now you have a voice assistant, when you do something really busy with your hand, then you still could interact with another system, which could help you or to guide you to finish your work. So this is kind of the scenarios that you could think of. Also the same, like if you're in the car and then you have your voice assistant or like your personal assistant help you guide your road with voice assist with you, then it's kind of like more easier. You don't have to always to see the model, what is the things happening there. Okay. And also another thing what I love would be conversational AI actually brings more higher accessibilities to different people. So for example, like if you are like people who take on your phone every day, you probably won't think of, there are some peoples they don't read at all. So for example, maybe one day that you become an elder that you probably won't read tiny words on cell phone anymore, then there will be really help if you have a voice assistant, then you just click the button and then just you to interact with the bot and then to help you complete the things. And also when you think of people who is blind, that could not read or they don't know what the things happen around, if you have the sensor could protect you and then interact with the blind people with the voice. So it's kind of like help them to get more connected to the world. So actually for me to think of AI is not only about make computer itself more smart, but also you could think of, there are also a lot of people like they need some help, and then with conversational AI or with easier AI accessibility, so that you could help them a bit better in their life. So next one, I'm going to show you 5 phases about a conversational AI. And this is reference that I got from Rasat, one of the open source that you could train your own intent model with it. So basically in Rasa, they proposed one of idea in 2018. So you could think of like the conversational AI have different phases or different levels. So some of you already start using chatbot or Q&A assistants in your company, so that you could probably would have the idea like which level that you are at right now. So, and the first one will be really beginning is like sending out just a notification. So you could think of it's like an alarm. So like every day it's 7 a.m. and then you got alarms that like, hey, you should wake up and make your breakfast. So it's kind of like a really easy. You could use that as like a reminder. And also, you could think of like for the notification, you could just say, hey, you need to pay your rent today. You need to do something. It's kind of easy to just set it up. And you don't need to like a lot of logic to play with it. You just need the time and then what are things you need to done and set it up. Another one will be FAQ assistant. I think also some of you have the experience like if you work in a customer service team, that every day, basically the customer, they always ask the same questions over and over again. So for you, it's kind of like really exhausted to just like answer their questions like over and over with the same answer over and over again. So from my experience, once that I helped my friend to manage their fans page on the Facebook, and then I saved their like customized time about like 80% just because we set up an FAQ system. So basically, you could imagine if you are a travel agency, what would be the top 10 questions that people will come to ask you? So it would be, hey, if I want to go to Germany, which place is the most place I could go to? So it's easier to think of like people ask like top 10 question would be like, where's the most place that you would recommend me to go? If I want to go to Berlin, you would recommend me to go to somewhere ABC. If I want to go to Munich, maybe you would recommend me to go to ABC, etc. So basically, if you set up an FAQ assistant, so the things like you will work the things more faster. So it's kind of like this. What would be the restaurants in Miami will open on Monday. So it's kind of like, oh yes, you would open on 11 a.m. and then close at 10 p.m. So then maybe you would like to know more regarding like the questions that you are answering, and then you could have more details on it. And also because you do like FAQ system, so that you basically set your time a bit more because everything is more automatically. But not everything is like prepared with Q&A maker. So there are some cases like there's some guests or there's some customers, they always speak something that you are not reading in your chatbot or you are not reading in your Q&A maker. So you still need something to remember your conversation. It's like, last time when he or she talked about this, what would be the values that they bring over? So you need something that could bring something like a conversational experience with you. So that would be the level 3 welcomes. So once, for example, if you see in these examples, like the chatbot asks, okay, so you want to just confirm is like 980 square feet for like the objects that you're asking. And then the next one will be, yes, so the new rent from September 1st onward will be $10 per month. Do you want me to renew it now? So you could see like September 1st would be something, the information that you already served or store before this conversation happens. So it's kind of like you keep track of what things happening, and then you have the better and customized experience for that. And based on that, the next level would be personalized assistance. So not only about one topics about you want to rent an apartment, you want to buy your stuff, and you also could remember a lot of different kind of aspects from your personal experience. So that I think this level, like level 4, is kind of like the things that we would like to work on a bit more in next 3 years. So especially this picture is being published by Russet in 2018. So they mentioned about in 3 to 5 years. So would be like a 2021 and 2023. So you can basically imagine now, like basically level 3 is kind of mature and people are kind of move forward to level 4. And then the level 5 where like everything automatically generated, and then it's kind of you could do everything's like just one click, and then it's help you to generate a lot of things on that. So if you want to mapping like the chatbot and conversational AI to like the automation driving, you could also think of like how autopilot could help us on driving, and then how the chatbot could help us on our life by automation. So you could think of like from the left-hand side, you could see from the 0 would be no automation. And then from the level 1 would be like a driver assistance. So you could mapping the level 1 we just mentioned earlier. It just like remind you, hey, something like you overspeed, you drive too fast, or there's something that you need to notice by like 5 p.m., etc. And then by the time that when you use more and more automation, that means you more and more trust to your system, and then you more and more have your own time to have more control about you want to drive a car or you want to do something else. Or let's take a chatbot example that you could think of like you want to answer your customers message by yourself, or you could take the time to do other things. Okay. So before that, let me check the YouTube message. Yeah. So there's Mikael Lai mentioned about that website is awesome. There will be a meetup this week in Berlin. Remote, of course. Yeah. So yeah, I would definitely recommend Rasa if you are more experienced on conversational AI already. This is really awesome. What platform would you recommend to get started with conversational AI? So I would quite recommend the one with if you just started everything like from scratch, you don't even know like the algorithms, you don't even know the intent and the entity that I want to talk about right now, then maybe you should start something like that Flow from Google or Louis from Microsoft, because it's kind of like partially is pre-built, and then you just learn some knowledge on it. So you could kind of like build your own like intelligent model by like from like really small knowledge, and then later on with Rasa that you actually have more abilities to customize what you want to do regarding like what actions that you want your bot to reflect, and then also what kind of like the actions that you want to do. Diaflow only gives you intent and entity, but you could not build flows. Can you? From my experience, yes, you could build the flows, but I remember the interface. I found it's not really convenient to see like the flows from the first dialogue, how the users flow to each one. So basically, I would say I use both Stackflow and also the Microsoft Louis, and then I found both of them have like advantage and disadvantage of them. And then for the Stackflow, I found it's a bit more easier if you want to integrate with the voice assistant. And then for the DOIS, I found it's more easier to integrate with Microsoft other solutions. So I think like if you were just start from scratch, you just want to have the first feeling about it, you could try both. So is there one platform for flow plus intents plus entities? As I remember, like for these two platforms that I use, would not 100% provide them all, but it's kind of like 80% that could fulfill what you need. And then once you're already familiar with one of them, then you're able to like customize based on the application that you're make on. Okay, so I will go back to the talk right now to talk about like intent and entity. So if some of you are not really familiar with it, you should know like something like intent and entity. That means if you have some conversations, you want to build some model, that you probably need know what your users want to do in your application. So for example, if you are a travel agency, people might want to book a flight, people would just want to say hi and bye, or people would just want to check out the weather or just check out if your service is still alive or nothing. So basically, like you need to know what would be the intents or what would be the actions that user need to do in your applications. And then the next one for the entities, that would be the different parameters that you will need to set up. So for example, like if I want to book a flight, what would be the entities that I need to find? I would need to know where's my guest want to fly with, like the destination, and then when they want to make book a flight. So for example, the date and then the time, and then like which cities they want to fly to and which cities they depart from, etc. So okay, so the next one will be so if you want to know, you want to book the flight rating and check the weather, you remember that again, the intent will be the actions you want to take in the application, and then the entity will be if you want to make this action, what different parameters that you will need the users to fill in. So you could easily to test a bit by yourself by clicking this link. So you could also search like LUIS service on the Microsoft Azure, then will lead you to this page. Then if you want to test yourself, if you're understanding the intent and then the entity enough, you could just click one of it and then to see why they plan the turn on as intent and why they put the left and the right as like different entities. So you will know like when you plan to make a chatbot, you need to make all your actions and then all your subjects that become the different entities. So like when you do different trainings on the LUIS, then you are able to define the things more quickly. So for example, if you go to the LUIS service on the Microsoft LUIS.ai, you will probably see like a lot of like intents that you could do in your applications. You could do confirm, you could check availabilities, you could cancel different things, etc. And then these are the actions that you want to take. Another one will be the entities you really take care of. You want to know if they want to cancel a meeting, when is the meeting and where's the meeting, etc. So the details that you want to make will put it in the entities. Okay. The next one that I want to show a bit more would be if you start using speech recognition, what would be the process about how exactly it works? So this graph, I use it from a paper called sentiment analysis on speaker-specific speech data. So this paper is quite interesting. If you have time, you could read through it. Or if you don't have time, you could basically, to check this graph would be the main idea that they want to share. So you could see in this graph, the upper side, you could see when you speak, your voice come to the computer, and then your computer want to know two things. So one thing's what's the content you're speaking right now. So if I say hello world, then my computer should recognize hello world. And the next one will be my computer would like to know who is speaking right now. So it's me or like my friends or my boss or my colleagues who is speaking. So sometimes in your application, you need to identify who is speaking. So if you are making applications that recording like all the meeting notes in your company, then you probably need the speaker ID. But if you just develop one applications which need to like translate and need to deliver something without knowing the ID, then it's fine. You don't need to know who is speaking right now. So you're able to know the first thing were like speaker discrimination, and another one were like speech recognition. After that, you parse your information and then make your own information as texture content, and then put your content to the sentiment model. So the sentiment model will help you to know, is it like a positive content, neutral content, or negative? Or even though if you have like the intent model, as I mentioned earlier, you could also run your intent model to know whether your users want to book a flight, whether your user want to cancel the meeting, etc. So as you know, like if you are handling with like speech data, actually they are look like this in the computer. So how's the computer to understand your voice is different from the others? So on the left hand side, you probably see the first will be like the dog bark is like bark, bark. So their distribution like this, and then the children playing, they're kind of like a meow, 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 meow. And then so it's kind of you see the voice itself with different frequency, and also with different height of the peak itself. So when you see the graph for different situation like street music or even like drilling, etc., you will see a lot of different voice has its own feature. So as you know, like the features is kind of like its character. So basically, when you're handling the voice data, you could think of like in the beginning, you see a lot of like waves, and then later on, you need to use like Fourier functions or other function to convert them as more easy understand the waves. So if you convert them into waves, will become like the right hand side as you see here. So even you see like we are all human speaking, like there are a lot of difference from female speakers and male speakers. And then also even if you are speak different languages. So for example, like I'm from Taiwan, so I speak Mandarin. So I think it's a bit similar to Chinese. And then for people who speak Swedish, Danish, and Norwegian, then you will see actually language itself, it has different values of peak value. So actually when you heard other people's from different country, they sounds differently, not only about the vocabulary itself, but also the sounds. It sounds like in a higher frequency or in lower frequency, etc. So when you see like the different voice, and you could think of if you do really care this different details in your application. If yes, then you definitely need to know more about this. If no, then you could just move on to the speech to text one. So if you are just first time to use speech recognition or to use voice data, then feel free to try it out like speaker recognition API and then speech to text API. So the first speaker recognition will actually provide the first speaker discrimination. It will identify different speakers or talk about right now, like who is speaking, speaker, like the main A, main B, main C, or the girl A, girl B, girl C. And then another one will speech to text. This one will provide you, like if you speak something in like the given language, like English, German, Mandarin, etc., and then it will help you to transfer your language as pure text. And then also some pricing that, as you see, some of the speech service, if you are just start to have like a trial to play with it, so it's kind of easy. And then you probably won't speak 5 hours for like a month for that if you're just testing your application. And I think like the free one will suit you. And if you are doing like an enterprise level, then you will need the standard one, the standard layer to have their service. So okay. Okay, I saw the question. What happened if speaker discrimination not able to identify the speaker? Yeah, so I think this is a good question because, for example, usually when you deliver the solution, sometimes one solution or one model doesn't work quite well. So in this case, I would suggest if you could also have a camera with you. So for example, if you are in the meeting right now, so let's say we are using Google Hangouts. So Google Hangouts always make the biggest screen for who is speaking right now. So as you see in the monitoring, the screen right now, you will see like my part. So if everyone open their camera, so you could kind of like, you have the face and then have the speaking the voice at the same time. So even though if there are two speakers, they sounds like really similar, you still have another model could help you to assist you, just prevent that if the speaker discrimination could not identify these two speakers. So you could think of like different ways. For example, if in our case, like today's meeting, we not always open our camera, but we have agenda, right? So you probably will know the first 30 minutes, Kristen will talk. The second 30 minutes, Mia will talk. So it's kind of like you're still able to label it by kind of like information that you could gather itself. So you could think of like AI itself is not 100% correct always, but it would help you to label things and automate things more faster. So I hope that will answer your question. And here I want to share you some quick. The code is kind of like really simple. If you want to work with speech API or the speech to text, I have a prepared .wef file, and then I want to run it as like 3 simple one, speech to text. Here and a second. It does not show the I thought before. I have to check that. So basically, what I prepared here would be originally I upload a web file here, and then it should go to the speech API regarding the settings that I set up here, the subscription key, and then the region that I set up would be Western Europe right now. And then later on, I set up my audio income would be the files, or either I use microphone. And here we'd go through the speech recognizers that to run the things here. Not sure it's already active. If I run speech, or the second one, So I guess I will need to check the first one a bit later, but I could demo the second one maybe. So for now, if I try to use speech to text, or another way is text to speech. So that means I use the same API and then I write it down like the text that I want to convert. And then another one will be after I turn this text, is like a turn on the light, and then you will generate a file for me, and then you would shows it. So if I click this one, review and finder, let me try. Turn on the light. You would see it. No, so you would hear the voice. Is it called like turn on the lights, and it sounds like someone from like the robot sound. Like the things I want to test here, the first will be if you have your file prepared, then you should able to parse it as like the text itself. And then another one will be if you have your text prepared, then you should able to also turn it back as like a file as well. So turn around. So I think that the last one I want to share would be some content a bit about the machine translation. So what I love is there's another service, is called like machine translation. It's like if you are speaking right now, let's say the English, and then later on if you speak someone who speaks Japanese, and then this service will help you to translate your own language to another language. So how it usually work would be the first will get the speak that you are saying right now is like the speech recognition. And then the next one will clean your text with like a true text within the function. So originally, like, can you hear me? Maybe the beginning would be like the hear. And then the next one will correct the spelling from you. Like, can you hear me with HER with the correct spelling? And then the next one with the correct answer, a correct text, then you will translate the can you hear me to the Japanese one. And then speech to the other users. So if you want to test it out this function, you could also try with speech translation. Actually, I found this one is really interesting, especially I won't say it's really interesting. It's more like convenient for myself because I moved to Germany for like 1 and a bit more year. So for me, I'm not really familiar with Germans, but I still need to do the paperwork at the government side. So it's like you still need to go to like foreign office, you still need to do and then you need to open your bank account, etc. So this kind of service will definitely help if you speak English but you speak really poor German, or if you are trying to travel to some places that you don't speak that language quite well. So in general, like I want to bring an overview about how to make a conversational AI application regarding like from scratch about how you will define an intent and how you define entities in your machine learning model, and then what kind of the tools that you could use it, you could search it, and then later on, actually you could see here, you could see a lot of like channels that you could basically integrate your chatbot in there. So for example, like one of the example would be use Slack, and you could integrate with like a Slack chatbot, and then so you could kind of like automatically do the text analysis in the channels that you're at in there, or you could also do it with the teams. So that since like everyone stay at home working right now, so like every day you spend a lot of time on Slack and also on Teams, that is kind of interesting if you just want to do some analysis with the topics on it. And then not only with different channels, but also you could think of like not only Microsoft, but also other cloud providers, they also have like a pre-trained model. You could try to like combine all of them together and to make some interesting applications. So I would definitely suggest you to have a look on Rasa, because I love it to use it. It's kind of like really convenient to customize a lot of things. And then it could also help you to manipulate your own dialogue itself, and then you could have more free to use it. But you would need more knowledge about what is the conversational topics about, and then also what is your domain and why you will need it. And then another cases that I want to share is a project that I worked previous in last year in one hackathon. It's called It's Alles in Ordnung. So that means also apply to, I don't speak really good German. So I could really imagine like sometimes when you walk on the street, or when you are in like Alexanderplatz, sometimes the U-Bahn just not coming for like 15 minutes. And then it's like, there's no one will tell you what is happening right now. So I made a chatbot that is like, I could speak my phone and then to say, hi, it's always no, and then you will connect to my service. My service was made in the Jackal floor. You could also replace them with a Lewis. And then this service will call an API on the Twitter. Then the Twitter API will share me what is the trending hashtag in the location that I am right now. So then it would help me to know what is happening right now at the moment and the place that I stand in right now. So it was a hackathon called like Voice and Traveling. So you could imagine like in this case, when you're traveling abroad that you don't actually speak the local language, you might in India, you might in like Thailand, or you might in like Brazil, etc. So there are a lot of countries that you would like to visit to, but sometimes you don't really speak their language. And then, so this case, like your chatbot will definitely help you if you don't have the knowledge about what is the things happening right now. Is everything okay? And then you could definitely find yourself a bit more secure during the time. So I think that's basically what I want to share today. There are some tips about how I learned conversational AI, and there are some like papers. If you want to read more, you could definitely check that. And then there are also a Rasa framework that I definitely recommend you. So if you also are having some project with the Rust application, that's feel free to write to me, and I would definitely like to discuss more on that. So I think that any questions?
Thank you very much, Mia, for your talk. Actually, you took all the questions during the talk already.
Yes.
So unless Abhishek doesn't
Yeah.
have an additional question, I would suggest, Trent, that we immediately move on to the next talk.
Yeah.
Abhi.
Okay, there's a final one.
Yes, it's Abhishek. Did
Yeah.
you?
The question is like, how does being able to see the trending Twitter topics in a very localized area going to help if the trend is laid without explanation? Yes. So at that time, I found Twitter not the only resources that I want to crowd at the time, because I also found that like the local police officers, like in website or the local police officer street is more helpful compared to just like the trending hashtag from the local net. So actually, I found this application still a lot of things to improve, because like if you go to travel in different country, there's a lot of different channels that people will publish their latest news and their latest status. So I think Twitter will be like the first step to start with, but later on, I think like it depends on different country, and then also different like the how urban it is like in the city level or is in the countryside. Definitely, there's a lot of things to add on.
Okay, thank you.
Yeah.
Thank you for your talk. Trent, will you do the introduction for the next talk?
Yeah.
Good. Hello again, everyone. So yes, the third talk has two speakers, Marvin Buss and Xander Matheson. Marvin is an Azure customer engineer at Microsoft with a focus on machine learning and data science, as well as ML ops and automating data science workflows. Xander is a data scientist at GitHub. He works with the Data Science Foundations team, which is focused on enhancing the experience and building capabilities for data scientists using GitHub. So with that, please take it away, Marvin and Xander.
Thank you. You should be able to share see my screen now.
Yeah.
Cool. Perfect. Cool. So then, thank you so much for the introduction. Thank you so much for your patience, and thanks for tuning in today under these weird circumstances. Still, we are really happy to share with you and really proud to share with you today what we have been building in the last couple of weeks and months. Again, yeah, quick introduction. I'm Marvin. I'm working at Microsoft as an Azure customer engineer, and we are helping customers around EMEA to move workloads into production. And today we are going to talk about productionalizing ML with GitHub and Azure ML. In the past, so I'm focused on data and AI, and I've been really passionate in the past about this ML ops topic. But before we start, I'm going to hand over to Xander, who's going to introduce himself as well shortly, and then we're going to start with the presentation.
Thanks, Marvin, and thank you everyone for joining today. So I am a data scientist at GitHub, and I was working on some data science problems we had there, and I realized that the experience for machine learning engineers and data scientists with GitHub was somewhat lacking. And so when the opportunity came around, I started working on how we could enhance GitHub to work better for data scientists. It's a relatively new endeavor, but nevertheless, we're starting in that direction. And one of the first things was trying to enable MLOps with actions via Azure machine learning. Not sure. Marvin?
Yeah, I can hear you.
Can we go to the next slide, please?
Yeah, sorry.
Okay, so a problem we all have probably faced in our work is there's a common story in the world of productionizing ML. Well, we can often develop a model with good results in a matter of weeks. Even mature organizations take months to deploy models. And this is embodied by this tweet here. We hear this countless times within our own organizations and with conversations with customers. And so this is where we got to the solution of MLOps. If we can go to the next slide, please. So MLOps is broadly a solution that helps data scientists control their end-to-end work and productionize their models. More in depth, next slide, please. MLOps is the conjunction of the developer operations with machine learning specific methodologies and tooling. So here we cover everything from the experiment phase through to the operationalizing phase. We're going to focus with these actions on the model testing, continuous integration, continuous deployment, and delivery, as well as the feedback loop and the monitoring of models post-deployment. Next slide, please. So some of the challenges and patterns we've seen in our experience has been some of the items listed below. It's very difficult for small teams to get started with machine learning because there's quite a large requirement in terms of scaling compute. There's a large amount of effort taking something like a notebook and making it into a production-ready endpoint. And oftentimes in larger organizations, you run into the problem where there's multiple teams involved taking a project from start to finish, and data scientists don't actually control the whole process. And so what we're going to try and do what we've tried to do with what we've been working on is empower and enable data scientists and give them control of the end-to-end process. All right, so I'll now hand off back to Marvin, who will cover a little bit about Azure Machine Learning.
Thank you, Zena. Yeah, so yeah, we have all been there, and it's kind of complicated, right? So machine learning encompasses all those different tools that you have to use for training, as well as for at some point deployment, right? And it's really difficult, and it's hard to manage all those tools and learn all those tools. And now it's a question of how did we really tackle this, the solution and the solution approach, and what kind of tools did we use? So on the one hand, we have something on Azure available, and we have learned about this earlier today during Christian's presentation. We have a service available called Azure Machine Learning, and this is really the go-to service for machine learning or data science on Azure. And I just want to quickly glimpse over it. I think you have seen quite a few details earlier on. But still, I want to just mention and make a few points here. So again, it's kind of a tool for all skill levels. Yes, you have the possibility to do some automated ML, where you basically just have to bring your own data, right? And then we will make sure that there's a model falling out at the end, which kind of fulfills the need in most cases. Then we also have this drag and drop possibility, right? Where you can basically use some boxes, connect them with each other, and by that train some models or even do some inference. Again, that's more or less for also giving the tools to some business analysts, for example. But what Azure Machine Learning really is about is a code-first experience, right? And I think that's the core and the core of the service here. And we really want to help data scientists who know Python, who know R, with getting all the tools together and simplifying the overall end-to-end process. So, right? So from data over training to finally production deployment, right? So that's really our goal here. And that's really front and center here in the service. And one really important thing that we have to mention all the time is this tool is open, right? So we're not going to tell you, go ahead and use CNTK. Those are the old days. I think we have changed quite a lot in the past, and we are really giving you the ability to use whatever you want and what you have been using in the past. So you can use any tool. You can stick to Jupyter Notebooks if you would like to, if you're used to that. You can use Visual Studio Code. It's a great tool, but you don't have to use it. You can use PyCharm. Do whatever you want. It's open. And the same is true for frameworks. So we are not going to tell you use TensorFlow because it runs best on our platform. You can just run whatever you want, right? It's all Docker and Conda based. So go ahead and train your models on Azure with our tools. And with those tools, if you bring them all together, what you can really do is you can build an industry-leading MLOps process. Something that we have quickly mentioned earlier, integrated with Azure. However, that's kind of complicated. And again, it requires you to, again, learn another library. It requires to learn some other tools again. And I think, and I believe with what we have built in the last couple of weeks, we really simplified the process so that you only maybe have to learn some GitHub Actions, and you will hear about that in a minute. But I think we simplified it a lot. And also what you've seen earlier today already is then where it comes all together, right, in this Azure Machine Learning service. So you have this visual interface, which you can use for interacting with the workspace, but we also have a Python and R SDK available, as well as the CLI. And yeah, basically, that's how it looks like, and we're going to show you more later on. And with that, I'm handing over to Xander, who's going to tell you something about GitHub Actions. Xander?
So we spoke previously a little bit about productionalizing ML with actions and AML. And so what are actions, for those that don't know, and how do actions fit in to this whole process? The next slide, please. So two things to differentiate between here to alleviate some confusion is we have the product or feature called GitHub Actions, and then we have the marketplace actions, which is what we will be referring to and what we can all build and share with the community. So the product GitHub Actions is a workflow engine that allows you to automate and customize and execute workflows in your repo. And these are YAML-based, and they're in one file, or sorry, in one directory in your repository. The individual marketplace actions are actually individual tasks within a workflow that you can develop, share, and reuse in your workflows. So you could build a workflow in a private repository using actions, or you could develop a marketplace action like we're going to show you in a bit, and you can share that with others or reuse it inside your organization. And so those are like modular, self-contained blocks of code, essentially. Next slide, please. So the gist of what we are trying to do is take the tool you're comfortable using for the reasons such as that you have used for a long time. It has version control. You can use it for knowledge sharing and collaboration, which is GitHub, and add to that via actions a way to automate your machine learning testing, model training, integrate a review process, and automate where required or where you would like with deployment. So without further ado, I'm going to turn it back to Marvin. He can show you how we have turned GitHub into a powerful tool for data scientists in this example.
Thank you, Zena. Yeah, so now we have those both tools I explained, right, as well as MLOps. So how does it all play together? And you can probably already imagine, yes, we have built some custom actions, GitHub actions for Azure Machine Learning. And we have come up with 5 different actions for now, actually. And one is there called AML Workspace, and that's basically available to create such a workspace that you have seen earlier, but it can also connect to one if there's already one existing for that you have created before. Then the second one, there's a compute compute action, AML minus compute, and that can handle basically compute targets. It can create new ones. It can check whether a compute target is available. Then there's a one action, which allows you to submit ones to experiments. So if one is essentially just an execution of a Python project with a set of hyperparameters, and that's something you can submit with the one action. Then the register model action actually does, the name already says it. It registers a machine learning model that you have produced in your one. In the workspace. So there's also a model registry available in the workspace itself, where you can then register with this action models into. And there's also model versioning available. And then the last one is the deploy action, which you can use basically to deploy machine learning models onto a container instance or on a Kubernetes cluster. And what we essentially did is not just create those actions, which is kind of nice, right? But we have also come up with with some templates that help you get started with machine learning and with MLOps in just a few minutes. So here I'm sharing a link already to one of the templates that we have available under the Machine Learning Apps organization. It's called ML Template Azure. And with just a few clicks and you're ready to go and train your first model on Azure Machine Learning. And then afterwards, you can bring your own model and your own code and your own data into it to really automate your full process end to end from training to deployment. And let me just share with you this video. So we have previously just created this one here so that you can see how simple it really is to get started. So what you're seeing here already is the template repository, right? So you can just click on use this template up there, which essentially creates a fork in your repository. And then you can just select any name, click on create repository. Yeah. And then again, what it essentially does, it creates a fork in your repository. It basically copies the code into your repository. Then further down in the README, you find some getting started as well guide. And here there's a command. So now we have to basically set up a connection between Azure Machine Learning and GitHub Action. And there's already a CLI code available, which helps you to get started to set up the service principal. So if you don't have a resource group ready to go, you can also create a new one, which I'm just showing here. However, you can also just use an existing one and even an existing workspace that you have ready to go, and just start from there. Here I'm creating a new workspace, and then in the Cloud CLI, which I'm opening right here, I'm using that to create a service principal. And why is that needed? It's basically needed so that the worker node, which executes the workflow on GitHub, can actually connect to your workspace and then interact with it through those actions. So what you're seeing here, yeah, it's the Cloud Shell. And there I'm going to paste the CLI command that's also in the README available. And there are just a few placeholders, such as service principal name. And there you can just select any name, whatever you like. Then you also have to provide a subscription ID, obviously. It has to be your subscription ID that you want to use, right? So that's something you can find on the top there in the resource group also. So you can just copy that and insert it into the command there. And then the last thing you have to provide is a resource group name, which is the one we just created here in this case, in this small video sample, which in this case, it's called MLOps. So, and then if we execute that, it's gonna create a small JSON output, which you will see in a minute or in a second, basically. There we go. I just masked it because with that, if you get access to that. So, and then I'm just copying that, and then I move back to my repository that I've just created. So now I'm just creating a secret in my repository under settings. And then if I click next on secrets, I can set up secrets here, which is basically a secret store, which I can use for my workflows. So now here I'm calling that Azure Credentials as described, and then I'm pasting the JSON output in there, and then it's created. And now the last thing I have to do is I have to set up the connection to the workspace. So I have to just provide some details to which workspace my action should actually connect to. And there's a specific file, a parameter that I have to change for that. And since I don't have a workspace set up yet, I can just pick any name and the action will actually create a new workspace for me. And then I'm also going to provide the resource group that I want to use, which in this case, again, is the MLOps name or the resource group that I have created before. So I just paste that in here, and then I'm ready to go, and I can commit my changes. So this already triggers my action that I have predefined. So now I can, my action workflow. So now I can click on the Actions tab, click on the execution there that was triggered, and now click on here. And what you see here, it's already triggered, and it's already starting to work with your workspace and connect to your workspace and so on and so forth. So in this case here, it takes the first one, it's going to take a little longer because it has to create a workspace new for me, right? It has to create also a compute target because I haven't set up one yet. And also the training one is going to take a little longer because it has to build a Conda environment as well as the Docker container all in the beginning. So all the subsequent ones are not going to take that long. It's just the first one which is going to take a little longer. And yeah, essentially what you're going to end up with is like a first success experience. You're going to do MLOps just by clicking a few buttons and creating a service principal. And you're going to end up with a deployment just in a few minutes. Let me just jump a bit further so that I can show you. Yeah, here it almost completed. So it just deploys the model now to an Azure container instance here. And in a few seconds, it should say completed. Just give it another moment. Oh. Yeah, again, the deployment just has to create like container, a Docker image, and then also deploy that. Yeah, there we go. It completed. And now I can go back to my resource group to see what has been done. And here you can see there was a workspace created for you. You can now launch the studio, which we have seen before. And there you can now see what has been created for you and what has been done with my GitHub workflow. So here, if you go to compute and compute clusters, you can see the GitHub cluster that was automatically created for you. Then when you go to experiments, you see an MLOps master experiment that was created for you. And then there's an initial one that we have just created. And there you can see also some metrics that were tracked and so on and so forth. Under outputs, you can also see the command line output of my script, as you see there. So I also created a confusion matrix. It's just a simple example here. And then in models, I can also see my model that was registered in the model registry. And I can also go then to endpoints and see that there was an endpoint deployed on a container instance, which is healthy. And now I can basically use this and send data to it and get results from it, which is rather cool, I think. And yeah, that's it for the video for now. I just want to quickly also jump to the let me just, sorry. So let me just jump to the repository. So what you can see here, again, I just want to quickly show you how simple it is and that there's not much to it. And a lot of the complexity is abstracted away from you, which is rather nice. So all you really have to take care of is obviously, so there's a .cloud.azure folder, which allows you to basically specify in some JSON files and parameterize and also control the whole run and execution of your Python scripts as well as the deployment. So there you have, for example, the workspace one, which we have looked at earlier. There's a compute one, which defines, well, if you clone it, it's just going to say GitHub cluster and please create a cluster for me, and it's going to handle itself. Yeah, that's basically it to the .cloud.azure folder. Then the GitHub workflows. Here you basically define your workflows that are triggered and executed. And here you will see all the actions that we have built in the background. So there's one called Azure/AML Workspace. So you can also find that repository on GitHub, which is open source. So feel free to also contribute to it if you would like. Then there's also a code folder, which is the one you should really care about. Like this is the core folder in which we expect you to work in. So there's a train folder in which you define your training script as well as some conda environment specifics. Then there's a deployment folder in which you define a score script, which essentially defines how your model should be loaded and how data should be scored against the model, right? So it's really simple and conda environment. And then there's also a test folder with which you can test your model deployment, and you can define some tests that should run against the deployed service itself. That's basically it. That's all to it. So it's really simple. I can also go in here and just show you. It's really simple. So there's one script and there's one environment YAML, right? So you can extend that and make a more complicated project. But it's rather simple. And yeah, so we can also show you that this is no fake. So if I just go in here, for example, go to my training script, right? I can just go in here. And then if I would like, for example, have a different test size, I can just do so, change the number there, commit the changes. And what you're going to see here under actions, you're going to see there's a workflow that was triggered. And that will basically now interact with my workspace that I've shown you earlier. So this just takes a few seconds to get started. And here we go. And with that, that's not all. There's a bit more. So obviously, this is just the most simple template that we have come up with. And there's a lot more to it. And I'm going to hand over to Xander to show you how a more enterprise-ready template could look like and share with you what else we are currently building.
Okay, thanks. Yeah, can you all see my screen? Yeah.
Yes.
Okay, so basically, what was shown there is Marvin has created these actions that kind of abstract some of the parts of the SDK to interact with AML that maybe as data scientists we don't actually want to have to deal with, or you don't have the overhead to deal with it. or the training to deal with it. We might not want to know what an AKS cluster needs to run our model. And so that was kind of the idea behind these. If you want to explore some of the different actions and read through the documentation, it's all available in the marketplace there, and you can also find them in the Azure org, just at github.com Azure. Here you'll be able to find the rest of the actions, so you can mess around with them, see the latest version, star them if you'd like. We'd appreciate that. Anyway, so we built them in a modular way because it's very difficult to encapsulate every single data scientist's workflow with one template. We might find it too restrictive for some of us. So I'm going to show you a way that we can extend this because they're modular. We can extend this to create a little bit of a different workflow. Let's say, for example, I author my notebook or whatever, and I convert it to a script. And then I'm going to train my model. And after I train my model, perhaps I want to review the PR. And if the PR is acceptable, I'm going to deploy the model. And I want to be able to track all those changes. And so we're going to use GitHub and Actions and AML to enable that. Now, this is already all done because it can take a significant amount of time. But so, similar to what Marvin did, just as a toy example here, I'll change my test size to 23%, and that will kick off a training run, which is very similar to what Marvin has already shown you. But in this scenario, I actually want the training run to tell me what my results were. So the GitHub Action bot will write back into my pull request the output of my experiment and where I can find information about this experiment on the AML dashboard if I wanted to dig into that more. It'll also give me the model name and the version, so then I can go and deploy this. So we rigged up some sort of chat ops here where we can deploy the model with the model name and the model version and to which environments we would like to deploy that. And so after I submit that, Actions will let me know where this was deployed to. I think this link will break. We'll see. So this job would be kicked off. I asked it to deploy to the development environment and the prod deployment environment, which use the AML deploy action. And in this case, it already succeeded. And once it succeeded, hop back into that pull request. And Actions will write back to me my endpoint or whatever I would like it to write back. So that's just kind of, I just wanted to kind of show that the extensibility of this, which I think is really cool. And I hope it will be useful for people in the future. And that about wraps up the presentation and our session.
Okay.
So yeah, thank you for joining. No one's made any comments about Star Wars Day today. So may the 4th be with you. If you want to reach out to myself, there's my GitHub email and my GitHub handle, and the same for Marvin. So thanks, everyone.
Thank you, Marvin. Thank you, Zander, for the talk. It's really cool.
Yep. Thanks also, everyone. And we are keen to hear about feedback, or if you have anything that you would like to see, please reach out to us. Really happy to hear about your thoughts.
Yeah, so there's one question regarding vendor lock-in. So you said, yeah, Microsoft has changed. It's much more open these days, but still viewers are not all that convinced. One asked, what happens when I go this way and want to change back to my presently existing pipeline? Is it difficult?
Yeah.
Well, I think.
Sorry.
Go ahead, Marvin.
So first of all, I think we as a platform also support most of the open source frameworks. And first of all, I think there are not a lot of solutions out there which tackle this issue of traceability and so on and so forth. There's, for example, MLflow available. There's Kubeflow available. And we are actually already supporting MLflow. So we have an MLflow integration. So we are also free to just use that one. So we don't even force you to use our SDK at all. On the other hand, integrating some of the logging to our Azure ML workspace isn't really that complicated. So it's just a few logging actions, and that's basically it that you have to include here to make it happen. So you don't really, it's not really about changing your code. There's not a lot of things that you have to do to bring your own code and change the overall process. But again, I think this tool really makes it easy for you to handle the automation at all. And yeah, Zen, I think you also wanted to mention something.
Yeah, I was just gonna mention sometimes you have like complex infrastructure requirements, and we do internally at GitHub. And for us to leverage something like this, we actually have to be able to split it and to use multiple different tools. And what is nice about this is we can actually move, like we can, because it's modular, we could do our training jobs with Argo on our internal infrastructure, but then we can register, serve our models to an S3 bucket, and then we can register them and deploy them with actions, with the AML actions. So there's also that to think out with respects to vendor locking.
Yeah, definitely. So at some point, yeah, you can also bring then your own model and just handle the deployment on Azure. You can also do it vice versa. So yeah, I think we are definitely not trying to force you using our tools and lock you in. But again, I think you can have that argument for any kind of tool that's out there.
Thank you. Actually, I have already a great fan for a GitHub action. That's Abhishek. Abhishek, do you have a question?
I think I see the question. GPU workers. So GPU. So you can run your own. In short, there is the ability to request the compute type in the future. Will there be, like if you use the actions, the compute that runs behind actions and you don't use your own self-hosted runners, I don't know if there will be GPU compute in the near future. But when you use your own self-hosted runners, there will be the ability to request the resource type in the future. So
yeah, but then, sorry.
In theory, if you require GPU for some of your build steps or for some of your workflow steps, you can just request that self-hosted runner with the GPU enabled.
But it's also kind of important to mention, well, those actions are not actually running the machine learning project on a or on any runner on GitHub, right? So they are executed on Azure Machine Learning, and on the platform you are free to use whatever you wanna. So there are GPU clusters available with 1 or 4 GPUs even for each single node. So you're free to use whatever you like there, and they are quite a few SKUs available, CPU or GPU based. And for AKS, for Kubernetes clusters, we even have some, now I forgot the name, different kind of CPU. That's not really important, but it's all available. So.
Okay. Thank you very much for your talk. Thank you, Christian. Thank you, Mia, for your talks. And do you want to wrap up, Trent or Abhishek? Trent, we can't hear you.
Oh, there we go. Let's see. So thank you, everyone, for being a part of this and for giving the talks. I guess that's all from my side. Hopefully you found it a good experience. Abhishek, anything?
Thank you very much.
Abhishek, we can't hear you.
Thank you very much. Nothing
Okay.
else from my side. It was great talks.
Great. Okay. Then I guess that's all. Have a great evening, guys.
Bye.
Take care.
Bye-bye.